Next, we have the contact stabilization. It uses two separate tanks for the treatment of wastewater and stabilization of activated sludge, which is mixed with the influent wastewater in a contact tank. The aeration volume requirements are typically 50% less than conventional plug flow. So, introduction of air in this contact stabilization process is not so by just 50% compared to the aeration volume that the original conventional plug flow have. Next is we have the extended aeration. Similar to conventional plug flow, except that it operates in the endogenous respiration phase of the growth curve, requires low organic loading and low aeration time. High rate aeration, from the word itself, high rate aeration, it is a combined with high volumetric loadings that allows high food and mass ratio. Next, we have the high purity oxygen. The oxygen is diffused into covered aeration tanks and is recirculated. The pH is adjusted and the amount of oxygen is 4 times greater than the amount that can be added by conventional aeration systems. Oxidation ditch consists of a ring or oval-shaped channel and is equipped with mechanical aeration devices. Screened wastewater enters the ditch, is aerated, and circulates at about 0.25 to 0.35 meters per second. The oxidation ditches typically operate in an extended aeration mode with long detention and solids retention times. We have also sequencing batch reactor. It is a fill and draw type reactor system involving a single complex mixed reactor in which all steps of the activated sludge process occur. Mixed liquor remains in the reactor during all the cycles, thereby eliminating the need for separation. Next, we have the trickling filters. It consists of a bed of coarse materials such as stone, slats, or plastic materials as a media over which wastewater is applied. This is a popular biologic treatment process. It is most widely used design is a bed of stones from 1 meter to 3 meters deep through which the wastewater passed that is distributed over the surface of rocks by a rotating arm. The rocks are 25 to 100 millimeters in diameter. But these trickling filters have certain limitations. Limitations like under organic loadings, slime growths, plug the void spaces between rocks, causing flooding and failure of the system. So, if the slime grows sa gitna ng mga spaces na between sa rocks na ginabuo mo for the filters, so it can fail the process or it can really fail the whole system. The volume void spaces is limited in a rock filter. And the other problems are the odor and the filter flies. And overcoming these limitations is that modules of corrugated plastic sheets and plastic rings that offers larger surface areas for slime growth with a 90 square meter per cubic meter of bulk volume and greatly increased void ratios. So materials are lighter than the rock. So you can just use plastic sheets rather than rocks if you would really like to overcome those limitations para wala ang problem doon sa trickling filters. And also, trickling filters are classified according to the applied hydraulic and organic load. An important element in trickling filter design is the provision for return of a portion of the effluent to flow through the filter, or what we call the recirculation ratio. It is a practice for plastic media to provide the desired wetting rate with a minimum of 25 to 60 meters per day to keep the microorganisms alive.